Good evening, sir. Here I am Ram Babu. You are 15CS308. Here in this experiment, I am going to explain about static routing. So for this experiment, you can see I have taken 5 router and 5 router and 4 switches. That means this will act as LAN 1, this will act as LAN 2, this will act as LAN 3, and this will act as LAN 4, and this is the WAN 1. This is the WAN 1, this is the WAN 2, and this is the WAN C. So first, before going to in the exercise part, first we have to understand what is static routing. Static routing is a form of routing that occurs when a router uses manually configured routing entry rather than information from a dynamic routing. In many cases, static routes are manually configured by a network administrator by adding in entries into a routing table. So you can see here I have in LAN 1 I have 1 switches and 2 end devices, and for the each end devices you can see I have assigned the IP address. So we did the subnetting here. For this we did the subnetting since we are having 8 subnet. Since we are having 8 subnets, so equally I have given IP address to all the subnets. So total is 256. So if we will divide 256 by 8, so each will contain each LAN and WAN will contain 32 block size address. So this LAN will contain 32, this LAN will contain 32 IP address, this LAN will contain 32, and this LAN will contain 32. Similarly, the WAN will also contain 32 block size, 32 IP addresses. So for each I have assigned the IP addresses. You can see for this it is connected with fast Ethernet 00 and its IP address is 1.1, and for this for broadcasting the message here itself it is showing like gateway, default gateway. I have given the default gateway, the last usable like 192.168.1.30. So here you can see in LAN A the second end devices it is showing 192.168.1.2. it is showing its IP address. Similarly, we have assigned the IP address for each end devices present in the LAN. You can see for this its IP address, for this end devices IP address is 1.65, for this IP address is 1.66, and for here LAN B two end devices is there. So you can see for this LAN network ID is .32 because this will be assigned from 0 to 31, and this will be assigned from 32 to 63, and this will be assigned from like 64 to 95, then it will assign from 96 to 127, and after that we will assign the IP address for the WAN. So at the place of router 0 you can see this is the default gateway that fast Ethernet we have given the IP address because this switch is connected from a router, so that it's needed because its interface is like fast Ethernet 00. So for that we have assigned the IP address, you can see 1.30, and again this router 0 and router 1 is connected by a serial 20 interface. So for that we have assigned a network address for this router for serial 20 interface, the IP address what we have assigned is 1.129. And now come here in for this router, since it is connected with a fast Ethernet, with the interface of LAN B, with the fast Ethernet 00 interface, so that we have assigned, you can see I have assigned a IP address for this interface 00, for the interface fast Ethernet 00, that 168 192.168.1.62, and for 20 and for 30 and this router 1 and router 2 is connected with serial 30 interface. So that what we did, like from here, for this router for serial 30 interface, we have assigned the IP address like 192.168.1.161. So now come in router 2, you can see from router 2 a LAN is connected. So a LAN is connected with fast Ethernet 00. So for that connection, we have given this router to we have assigned this router to a IP address with, you can see here, fast Ethernet 00 192.168.1.94. Since it is subnetting and it is borrowing 3 bit, so the notation is /27. So you can see, and again you can see here this router 2 and router 3 is connected. So for that one IP address we have to assign. So and it is connected with, and router 0 and router 1 and router 2 is also connected. So for that also, for serial 20 interface, we have assigned 192.168.1.190. For the connection of router 0 and router 1, we have assigned the IP address. And then again, this router 2 and router 3 is connected, so that for that connection we have assigned IP address like 192.168.1.193. So come in the same way, for the router 3, you can see the connection of router 3. Router 3 is connected with the router 2, and finally it is connected to the router 4. This many connection is this router 3 is having. So this will be having 2 IP addresses. So one is serial interface 30, because it is connected with router 2 to router 3. So it is applying the connection with the interface 30. So you can see here, for serial 20, it is we have assigned a value 192.168.1.222. and for since it is connected with router 4 also, so that it will be having the IP addresses of serial 3 interface serial 30, that is 192.168.1.225. So in the same way, for the router 4, you can see here, like router 4 is connected with LAN D and router 3. So this router is able to know about the LAN D and the WAN C, so that we are going to assign the IP address for this. So it is like LAN D is connected with the fast Ethernet 00 interface. So for that we have assigned the IP address 192.168.1.126. and you can see like for this like it is also connected with router 3. So for with the interface of 20, so with the interface of 20, so for this the IP address is 190. So the IP address is 192.168.1.254. So this was the these all were the assignment of the IP address to all the LAN and WAN devices. So now for the static routing, as per I told you already, like static, in many cases static routes are manually configured by a network administrator by adding in entries into a routing table. So what you can think in this connection, like you can see, as per the definition of the static routing, you can see this router 0. This router 0 is only able to know about the devices connected in the LAN A and the devices connected in the route, and the devices connected in the router 2. In the same way, this router is only able to know about this LAN devices, about this router, and about this router. So, and this router is only able to know about the LAN D end devices connection and for this router connection. So you can see, I will tell you one thing, like for this for router 0, router 3 will be the remote network, that it can't be able to know what is the connection or what is the IP address assignment for the end devices which is connected with the router 3. So for that purpose only we will use the static routing. So what will happen, I will show you. The command line interface, enable. So here you can see, as per the definition, that network administrator used to give the IP address, give the network ID manually to the router at the CLI interface, at the command line interface. So you can see this router is connected because this router is only able to know about the LAN A devices and the router 1. So it is not able to know about what is happening in the router 3 or router 4 or router 2 end devices. So for that purpose only, manually we have configured the network ID to the router 1. In the same way we are going to give the network ID to all the router. So enable, so IP root. So here also you can see, in the same way, directly connected, first it is only connected with router 1, it is connected with 32, and one more that with 128 it is directly connected. So rest of the network ID manually the network administrator should configure in the routing table. So it is showing the routing table for router 1, and in the same way for router 3, you can see here, in the same way what I have told you for the previous two router, in the same way we have manually configured the network ID, that from that it can be able to know about the remote network to that router. So again check for router 3, this you can see router 3, and you can see this command line interface and the routing table. You can see the routing table of router 4. So now by the static routing, now this connection, now all router is able to know about all the LAN and WAN devices, because we have manually configured the network ID to each router. So I want to broadcast a message from this PC0 to this PC0 from LAN A to this PC4 of LAN D. So what I will do, sorry. For that purpose we have to assign a default gateway. So from where we are sending the message, for that end devices we have to give the default gateway and the destination destination and devices we have to assign with default gateway. So what we'll do, like we'll take a message and we'll configure from here to here. So now again I will take here. Then I will capture and forward, then again capture and forward, it is going with the router 2, with the router 0 it is coming by the default gateway. And since for that only we have configured the network ID, so now you will see. Then again capture and forward, and now it is at router 1, capture and forward, now at router 2, capture and forward, now at router 3, again we can see here. Then again capture and forward, then capture and forward. So now it is coming at the destination. So again capture and forward, it is receiving and sending the data back, sending the message back, and again capture and forward at router 3, then again at router 2, then again at router 1. So now I will show you. So now it is coming at router while coming by router 0, it should come here at PC node. So again capture and forward, and then capture and forward. So now it is coming, and here we are receiving the message what we have sent to the destination, and we have received the message, broadcast message. So this all was about static routing. Thank you very much.